All right, so in this video, we're going to be looking at decomposing complex functions into simpler functions, in particular two functions, f and g. So we want to find f of x and g of x such that h of x is equal to f of g. And again, in other alternative notation, the composition. Now, for many of these examples, and I put 3 examples up here that we can work with, for many of these examples, there may be more than one way to do this. And so you do not have to necessarily always come to the same result. And I may show you in some of these cases other ways that you can do this, so that you still have a composition, but they're not identical decompositions in each case. But generally speaking, you don't have to overthink this. Generally, if you've got some sort of global behavior, you want to think about using that as your f function, and then anything that's on the inside, think about that being the inside function. So let's take our first example. In this case, we have something raised to the 4th power. So the function, there we go. The function on the outside, that's our f function, is something to the 4th power. And then the thing on the inside is just whatever is on the inside. As long as when you recompose the functions, you get back to the one that they gave you, your answer is fine. Now, in this case, this is the most obvious solution. Let's look at our second example. Now, in this case, again, the most obvious case is I have a cube root on the outside. So I'm going to let my cube root of something. And then my g of x will just be whatever is under the cube root. So 4 minus 7x. However, I don't have to only do it that way. I could, for example, let f of x be equal to the cube root of 4 minus x. So it's a slightly more complicated outside function. And then my g function is replacing x with 7x. Or I could do the cube root of 4 plus x, and then g would be negative 7x. So again, there's not a universal, there's only one way to do this. You'll see when you take calculus that this type of example is sort of the preferred one because of the way that our things that we do in calculus work. But for this class, you are being asked to write them as a composition. And as long as when you recompose them, you get back to the correct answer, the original function, then your example is fine. Your decomposition is not incorrect. Let's look at our last example. Now, in this example, if we had identical numerator and denominator, so this was 2x minus 3 and 2x minus 3, then I would say make your inside function 2x minus 3, and then the outside function would be the rational thing. However, in this case, we can't do that because the signs are different. So there are still other ways that you can decompose this. But the sort of obvious way would be the outside function would be the absolute value of something. In this case, absolute value of something plus 3, and then divided by something minus 3. And then your g of x would be 2x. Again, we have to do it this way in this example because of the sign change. If the signs were identical, then we would be able to say like f of x could be absolute value of x over x, and then our g function would be the 2x and the constant. But because the signs are different, we can't do that. So this is, again, the most obvious solution. But again, the idea here is you're taking apart the function, you're taking it apart into less complex pieces. Sometimes less complex actually does seem like it's much less complex. And other times you really have to leave quite a bit of complexity in one or the other of your functions in order to decompose it even a little bit. So again, there's not only ever one perfect answer in most of these cases. Sometimes there will be an obvious answer. Sometimes there will be multiple ways to do it. But as long as if you retest it and you check when you do the recomposition F composed of G, do you get back to the original H? And if that works, you should be fine.